Hey, it's Finley, and today we're going to go over Module 6 discussion post, the B and T cell immune deficiencies. So before we get into those immune deficiencies and then what diseases can be diagnosed when those deficiencies occur, we're going to get into a little bit of foundational knowledge of the B and T cells. So starting off with B cells, they are found in the spleen, the maw, and the lymph nodes. They can be found freely floating in the blood as well as attached to the cytoplasmic reticulum when they create the B cell receptors to help with the specific attack on a pathogen. So when the B cell then becomes stimulated, a unique BCR is then developed, and then cell division then occurs that only that BCR is then going to be the offspring. So then we have multiple versions of that BCR to then attack that pathogen. So then it's secreted into the blood and or the lymph. So then it has that double duty where it's only where then the pathogens are found. And these are called immunoglobulins. Immunoglobulins. It's a hard word. And so then when they're activated, then they are the plasma cells. So when the plasma cells then are created, when it has that specific BCR, the BCR is actually not a thing anymore. We have a higher amount of endoplasmic reticulum, the rough kind, as well as Golgi bodies. The genes are randomly generated to then help with the immune system, and it predominantly attacks bacteria. So now getting into a little bit of foundational knowledge of then the T cells, they harbor intracellular pathogens, predominantly viruses, as well as abnormal antigens that cause cancer. So it's produced in the bone marrow, so it's a little bit more specific to us, but it's all specific to us based off of what we've been exposed to with being this type of immunity. And the thymus is where then the T cells grow and mature, and then it circulates through the blood and lymph. And like the B cells, it has a T cell receptor, and then it has a random generation or choosing of DNA to then help with the specific attacks on pathogens. So something that I found interesting when looking in the deficiencies that can occur in B and T cells is that it could be too much or too little, as opposed to just the right amount. And so when we're looking at that and looking at B cells, if we have an acute amount of B cells or a low avidity, it causes ignorance within the B cells. And so it's like they don't know what to attack. As opposed to if there's a high avidity or an overactive amount of B cells, then it causes deletion. And so what we'll see in the overactive amount, it causes a lot of autoimmune diseases like leukemia. And we also see that same effect if the T cells are then too active. Leukemia has both traits of B cells and T cells being too active and not knowing what to attack. And so then it attacks its own body because then it thinks it's a pathogen, or it puts that receptor on it to where then the T cell then attacks it. So if the B cells are not present at all, or they're so inactive that they are incapable of maturing, we'll see something called a gamma globulinemia be diagnosed to people. And bacterial sepsis is something that's commonly diagnosed, or a trait of this, as well as the absence of globulin fraction. So then when we have an underactive of T cells, since I kind of already went over overactive T cells, underactive, there will be an exhaustion of T cells. So Imagine if you ran a marathon and then you went and worked out and then you just had to keep going. You're going to be exhausted. And so that's kind of where the T cells are at this point in this analogy. And so when the T cells are underactive, lupus, rheumatoid arthritis, multiple sclerosis, type 1 diabetes even tends to then be diagnosed because it has such a low level of immunity that then other things then become a problem. And a primary disease that's associated with underactive T cells is DeGeorge syndrome, or congenital thymic condition. So that's all that I have. And the resources that I used in addition to the textbook today was the clevelandclinic.org website to then get a little bit more understanding of the symptoms and diseases that can be diagnosed with underactive or overactive B and T cells in the National Institute of Health. So until next time, guys.